So in this video, let's try to look into what is encoding, encryption, and hashing mechanisms and how they can be useful to our password management in any web application. So the very first basic approach that any application follow is encoding. So encoding is a process or a mechanism converting data from one form to another form. So there is nothing related to cryptography here, like they don't encrypt or convert into some form where others can't understand. It's just that they follow an algorithm, like I may have a data 1 2 3 4 5. So instead of sending plain text, or which is very simple way of understanding for users to understand who are intercepting my request, I may follow a process or algorithm that I will encode it to by reversing it. Like instead of sending 1 2 3 4 5, I will send to my backend 5 4 3 2 1, and in the backend I'll have a logic or algorithm to reverse it again to see what is the original text. So this is one of the basic way of protecting your passwords or any information where you don't want anyone to read or understand without any efforts. But encoding lacks all properties, like it lacks confidentiality, integrity, and authenticity. The reason is anyone can decode your encoding request data that you have sent. Like I may send some data password, but decoding it is very easy if someone knows that this is the encoding approach that I am following. So encoding is a process where we convert data from one form to another form. That doesn't mean people can't understand what is my original text or plain text that I initially sent. So there are good mechanisms for decoding and converting into a original text form. That's why encoding should not be used for securing data or any passwords that you don't want exposed for public. But where do we use this encoding? So encoding we use mostly like converting data from one form to another form, like for compressing my data. Like I want to send a data to the backend, but instead of sending it in original form like an image or audio, I'll compress it like into a binary format, which means I encode into a binary format and I'll send to backend, and my backend will have a decoding mechanism to derive the original format. Most of the encodings that we have is base64 encoding, Unicode, ASCII encodings, which usually web applications use for their URL parameters that they expose in the browser or sending any header information inside HTTPS. So for all such requests or all such scenarios, we use encoding. But as per our discussion, encoding clearly is not eligible to maintain our passwords. It clearly can't protect our passwords from hackers or some unwanted people who want to try to access the passwords. So then let's look at the encryption. I would say encryption is the next advanced version of encoding, because even in encryption, the reverse is possible. Like if I encrypt a text, like 1234 has been encrypted into some random encryption text. While encrypting it, I use a key. So I may use any algorithm. For that algorithm, I pass a secret key which my encryption algorithm uses to encrypt it, and whoever want to decrypt or reverse it to original text, they should know the key that I used initially. So without the key, it is impossible almost to decrypt my encrypted value to the original text. That means this is far better than encoding, because in encoding there is no secret key. So if everyone knows like what is the algorithm that I am using, like base64 or ASCII or Unicode, they can easily decode it. But here, even though they know my algorithm name, they can't decrypt it because it is associated with a secret key. But again, in encryption, we have two different categories. One is symmetric and other one is asymmetric. In symmetric encryption algorithm, a single secret key will be maintained by the both parties, like whoever is encrypting at one side and whoever is taking that encryption data and try to decrypt it, they follow the same secret key. So this you can use if you are sure that no one can misuse your original key. In such scenarios, we can go to symmetric encryption. Suppose Think like there are two backend applications or microservices that are trying to communicate with each other. And one microservices is trying to encrypt it and send to the microservice 2. And microservice 2 is trying to decrypt it using the same key used by microservice 1. So in this scenario, if you own both microservice 1 and microservice 2, then you are free to use the same secret key because anyways both the microservices is maintained by the same organization or same web application, and there is no harm of using the same secret key. And as long as the key is protected, we should be good with this encryption mechanism. But again, here there is a problem. Whatever security measures that you can use, you have to store this key in somewhere, either in your environmental variables or system variables or in some your externalized properties where our server admins can easily understand it. So if someone knows the key, like our server admins, they can easily decrypt our passwords. That's why encryption symmetric approach also is not apt for our password management. Now let's look into the asymmetric encryption algorithm. So in asymmetric, what will happen is there will be two keys. One is called as public key and other one is called as private key. The person or the system which has public key is responsible to use that and encrypt the data. And public key is accessible to anyone. Like whenever I access any web application or any website, you might be seeing HTTPS, which is a SSL or TLS certificates. So whatever we see that green color in our browsers, that indicates public certificate installed on my browser for that website. So when I have my public certificate or public key on my browser, I can enter my username and credentials. They will be encrypted and be sent to the backend server which maintains that website. So my backend application will have a private key, and only who has private key can decrypt the data which is originally encrypted by a public key. So someone can copy or take my public key. There is no harm because using public key, you can only always encrypt the data, but you can't decrypt it. So in asymmetric encryption algorithms, so public key and private key is responsible for our encryption. But again, this has the same problem as symmetric encryption is whoever knows the private key, they can easily decrypt your data or password and they can hack your application. So again, encryption also is not suitable for our password management. And the scenarios where you see encryption in our day-to-day basis is symmetric encryption. You can see whenever you try to store some secure data inside your database, like credit card information or my sensitive PII information like date of birth or my phone number, but not the password because password is very sensitive in nature, and with that password anyone access your application. And similarly, in asymmetric encryption, it is used in TLS securities, VPN, SSH, where two different parties maintain different keys, which is public and private key. The reason that why we are not maintaining the same key is they are two different parties, and I'm a owner of web application and I'm maintaining private key. I'm not sure whether the other side party may maintain the same secrecy towards my private key. That's why I will never share my private key to anyone. Instead, I will give a public key to them using which they can encrypt, and whoever has the private key associated to that public key only can decrypt that information. But again, as we discussed, encryption is not suitable for password management. Then what is suitable? Let's look at the hashing. Like we discussed, even in the encoding and encryption, the reversible is possible. Like someone knows the key or encoding algorithm, they can easily reverse to my original text that I have stored in the database or sent over the network. But hashing is a powerful algorithm or a mechanism or a process where it hashes whatever input that you give, it will hashes using a hashing function, and it is non-reversible. That means once you generated a hash out of a string and you have a hash inside your database and stored it, no one can reverse it and see the original text. That's the beauty of hashing. But you can say, how then passwords can be compared? Think of a scenario, very first time the user entered his password while registration. At that time, I generate a hash password and stored it to the database. Now, even though my server, DBA server can see that encrypted hashing text inside the database, it's useless for him because he can't reverse it to see the original text. Next time, the user is trying to log in into the web application using the password associated to him. So now he entered the same password 12345. So now my application will try to generate a hash out of it, and it will try to compare the hash that we stored inside database and the hash that we have in our hand based upon what user entered in the browser. If both hashes matches, then that means the password is same. There is a very good chances the hash of the both what we stored in the database and what we received from the user for the same text can look different, but their hash value which used by the hashing mechanism will be same. That's where when they try to compare the hashes of the same text, they will always return okay, the both hashes are matches, which indicates that these are from the same text value. So that means hashing can be leveraged for our password management. And one of the other approach that you can always see for hashing in the web is in most of the websites when you try to download the files or software dumps, they'll give a checksum associated to that file. That means this is the hash based upon the content that we have on the file and whoever download it, and make sure after downloaded in the process of downloading from the network no one changes the data inside it. We can always rely on the hashing function to generate a hash and compare with the what initial hash that they provided on the website. So that will tell you okay, there is no change of data and both original and what I downloaded are same. So now it's very clear, encoding and encryption, though they have scenarios where we can leverage them, but they are clearly losers in terms of password management. The clear winner here during password management is hashing. The reason is there is no way for users to reverse it and see the original text. I hope you are understanding this. Let's try to understand in the next video with hashing how Spring Security works. Thank you. Bye.